All right, CNT120, we are working on Chapter 4 on network protocols and routing. So we're going to want to get a handle on some of the TCP/IP core protocols, TCP, UDP, IP, that kind of thing. Start to explain their function header, and how they're formatted. Talk a little bit about routers, and then various TCP/IP utilities that we'll use for troubleshooting. All right, let's dig in. First part they talk about is the TCP/IP core protocols. Yes, indeedy. TCP/IP is actually really a protocol suite, or as I like to call it, kind of like a bucket of protocols. And the idea is when they developed TCP/IP, it was really kind of a, hey, here's a bucket of protocols, and if you want to do, I'm going to fill in the blank here. Hey, if you want to send an email, use SMTP protocol. If you want to load a web page, use HTTP protocol. If you want to send a file, use FTP protocol. So there were a whole bunch of protocols developed to do these specific functions. And with them is the core things like TCP, IP, UDP that are the core of this TCP/IP protocol stack. So it really is a protocol suite or a bucket of protocols. And a lot of times people just shortcut to IP or TCP/IP. This was developed by Department of Defense, DoD, with the DARPA project, Defense Advanced Research Projects Agency, in the 60s ballpark. This is the precursor of the internet. That's where this came from. That's where the TCP/IP core protocols came from. The idea was, and the advantage of them is its open nature. It does not cost anything to use. There's no licensing costs. You can install it and use it, and away you go. It runs on pretty much all of our operating systems now. Once upon a time, our operating systems were proprietary. They did their own set of protocols for their own network using their own network technology and cabling and so forth. Now it has been ported that pretty much all of our operating systems use TCP/IP. And it'll allow connecting different operating systems together. Think about Apple computers and Windows desktops and Android phones and Apple phones and Linux computers. And all of those now can communicate using TCP/IP. So real quickly, I'm just going to remind you, if I were to open my network settings here on my Windows machine, let me slide this over, scroll down here to Network and Sharing, and take a peek at my Ethernet 3 settings, what I'll see is TCP/IP is installed and ready to go. Once upon a time, you actually had to go through the process of installing this. You actually had to say install protocol blah blah blah. Now our operating systems come with it already installed and ready to go. So there's my Windows machine running TCP/IP, and just out of curiosity, I have my Linux VM running. If I go into here where its network settings are, and start looking at its network settings, it's running or it's using an IP address. But if I were to go in here and alter the IP address setting changes, take a look. IP version 4, IP version 6. It is there, installed and ready to go. Our operating systems, all of our operating systems run TCP/IP, hence why we're able to communicate globally on the internet with this. With that was developed the TCP/IP model. So we learned the OSI model. TCP/IP has its own model. It's really just a condensed or a compressed version of the OSI model. It really has 4 layers: application, transport, internet, and network access. Okay. So if I were to take a look at, here's the OSI model that we're used to over here: application, pre-station, session, transport, network, downlink, physical. If I look at the TCP/IP model now, and I'm mentioning this because kind of here on out, a lot of your reading is going to be focused on TCP/IP model. The top 3 layers of the OSI model are combined into the top layer of the TCP/IP model, application layer. And it kind of makes sense. All of those functions are done in, kind of like one layer could kind of combine all of those. Transport layer is still transport layer. Internet layer is just a different name for network layer, and the network access layer is a name for combining the downlink and physical, which actually makes sense too. My network card snaps into my computer, it gets me access to the network, and it also connects into my network either with a cable or wirelessly. So this piece right down here, my NIC kind of does these 2 functions right down here. So there's your TCP/IP model. They also start reminding you that TCP/IP is routable. Yep. And the protocols add a header to each chunk of data or each piece of information passed to it from the upper layer. So reminding us, if I have my browser and I'm asking for something from a web server, I'm going to take my HTTP request, package it up. There's the HTTP request with the TCP header. All of that stuff becomes the data field for the IP, and here's the IP header. All of that becomes the data field for the Ethernet header frame here. Okay, remember we did the Lego blocks or talked about putting all the header fields on. This is my computer packaging up the data, encapsulating it to send across the network. Once it gets to the web server, it's going to depackage or de-encapsulate the data. It'll start pulling off the Ethernet header, looking at the payload inside, then pull off the IP header, look at the payload inside, pull off the TCP header, look at the payload inside, and eventually take this payload and display it in the web server as a request of, hey, somebody wants the web page, would you send it to them? And it would reverse the process. Well, they're reminding us, hey, every time data is passed down through the OSI model, a header is added at each layer. And that header has information that the other machine at its corresponding layer will read. So this TCP header here is really there for the web server to look at that TCP header to understand what's going on. Okay, that's what they're trying to tell you with this picture here. And I'm trying to remind you what we talked about back in Chapter 1 about our data encapsulation process. I have data up at the application layer. That's basically an HTTP request. Presentation layer, make sure it's in a format that the other end can read. Session layer, make sure the session is open and ready to communicate with the web server, if you will. Once it gets to layer 4, typically a TCP header is added. That'll have the port number in of the application we're trying to talk to on the other end. Layer 3, an IP header gets added. That's the IP address of, our web server in this case, the web server we're trying to talk to. When it gets to layer 2, we're going to add the Ethernet header. This will be the MAC address of that device that we're trying to talk to. And then at the physical layer, all this gets turned into ones and zeros and sent across the network. And this process is reversed on the other end. So when they show you a picture back here of this, that's what they're really trying to get at. They're trying to get at this encapsulation process that we talked about before. Adding a header at each layer, sent across the network, and then that gets reversed on the other end. And that's also the picture they show you. Like to show you these pictures in the book too. I'll encapsulate here across the network, de-encapsulate over here. Remember, at each layer, there is a name for the data at that layer, protocol data unit. And that's where we came up with the data segment packet frame bit. Don't send fill for bill. Remember those two. Don't forget those. Data segment packet frame bit. Don't send fill for bill. Okay? Remember that little shortcut. And then the other end, this actually, I jumped ahead myself, but the other end is going to de-encapsulate. Yes, as it receives it, it'll pull it back apart so it can read it and send it to its appropriate application running on its node, or its device, if you will. They also remind us that connectivity devices, things like switches, routers, firewalls, are typically called or referred to by the highest layer that they read. So switches are going to typically read layer 2 headers, MAC addresses. So typically they'll say a switch is a layer 2 device. Routers are typically going to read IP headers or IP addresses, which is layer 3. So again, routers are typically called a layer 3 device. Firewalls will typically read TCP headers or higher. So they tend to be called a layer 4 device or higher, depending on what it's doing. Some firewalls can read higher than that, but a lot will read layer 4 TCP port numbers. So typically called a layer 4 device. And that's what they're trying to show with this picture here too. And that they're referred to by the highest layer that they read and understand and maybe even filter or make decisions based on. All right, and that gets us to the first core protocol, which I'm going to come back to in the next podcast.